Right now, a million miles from where you are sitting, a machine the size of a tennis court is staring into the dark. It is colder than almost anywhere in the solar system. No human hand will ever touch it again. No astronaut can reach it. If something breaks, it stays broken, forever. This is the James Webb Space Telescope. It cost $10 billion and 3 decades to build, and it is the most complex object NASA has ever flown. To get it there, engineers had to fold a telescope too large for any rocket like a piece of origami, fire it into the void, and trust it to unfold itself perfectly, on the first attempt with no second chances. Why would anyone take a risk that insane? Because of what this machine can see. Webb was built to catch light that has been traveling for 13 billion years, light from the very first stars and galaxies that ever switched on, after the universe went dark. To see the beginning of everything, they had to build something that had no right to work. This is the story of how they built it. For 3 decades, the Hubble Space Telescope showed us the universe in breathtaking detail, but Hubble had a wall it could never cross. As the universe expands, the light from the most distant galaxies gets stretched. Visible light, the kind your eyes can see, is pulled into longer and longer wavelengths until it slips into the infrared. By the time the glow of the first galaxies reaches us, it has become heat. And to that kind of light, Hubble was effectively blind. To see the dawn of the universe, you need an infrared telescope. But infrared is just another word for heat, and that creates a brutal problem. A warm telescope glows in infrared. It would blind itself with its own warmth, like trying to photograph a single candle from inside a burning house. So the machine has to be enormous, to gather light from objects almost too faint to detect, and it has to be colder than deep space itself. Bigger and colder at the same time, in orbit, with no one to ever service it. If you are finding this as remarkable as we do, hit subscribe. We tell the real story behind the world's greatest builds, because everything about Webb came down to those 2 impossible demands. Start with the size. To catch light that faint, Webb needed a primary mirror 6.5 meters across, nearly 3 times the width of Hubble's main mirror, with roughly 6 times the light gathering area. There was just one problem. No rocket on Earth has a nose cone wide enough to hold a mirror that big. The fairing of the rocket that would carry it was barely 5 meters across. The mirror simply would not fit. An engineer staring at that contradiction has 2 choices: build a smaller telescope and give up on ever seeing the first galaxies, or build a mirror that folds. The team chose the impossible option. They would split the mirror into 18 separate hexagonal segments, hinge the outer wings and fold them back like the leaves of a dropleaf table. The vast Sunshield would be pleated and packed like a parachute. The entire observatory would become origami, collapsed down to fit inside the rocket, then commanded to bloom open once it reached space. No one had ever flown a telescope that unfolds itself in orbit, and the list of things that had to go exactly right was about to get terrifying. Here is what made Webb the most nerve-wracking machine NASA has ever attempted. To open up in space, it had to perform a sequence of roughly 344 single-point failures. Engineers have a chilling name for these. A single-point failure is a step with no backup. If it fails, there is no second motor, no spare latch, no redundant system to take over. The mission simply ends. Hubble had a mere handful of these. Webb had 344 separate motions, booms extending, membranes unrolling, hinges swinging, latches snapping shut, every one of which had to fire flawlessly, in order, a million miles from any astronaut who could intervene. The math is unforgiving. If each step had a 99% chance of working, stringing all of them together would still leave the whole sequence near coin flip odds. So 99% was nowhere near good enough. Every mechanism had to approach perfection. NASA was about to bet $10 billion and 3 decades of work on hundreds of things going right, the very first time they were ever attempted in deep space. To understand where they found the nerve to even try, you have to look closely at the machine they were building. The mirror is where Webb's impossibility turns beautiful. Each of the 18 segments is cut from beryllium, a metal that is light, stiff, and holds its shape even when chilled to hundreds of degrees below zero. Ordinary glass would warp in that kind of cold. Beryllium barely flinches. Each segment was ground and polished to a smoothness almost beyond comprehension. If you scaled a single segment up to the size of the United States, the tallest bump left on its surface would be just a few inches high. Then came the gold. Every segment was coated with a layer of pure gold so thin it is measured in atoms, a few millionths of a meter, because gold is an almost perfect mirror for infrared light. The result is that famous honeycomb of golden hexagons, 6.5 meters wide, able to gather the faintest whisper of ancient starlight. But a mirror this sensitive carries a curse. It can only detect the faint heat of distant galaxies if it is kept brutally, impossibly cold. A few degrees too warm, and the telescope's own glow would drown out everything it was sent to find, which meant the engineers now faced their second monster, keeping a tennis court-sized machine colder than deep space. The sun is the enemy. At Webb's mirror, sunlight pours in with enough energy to keep the whole instrument far too warm to ever work. The solution is one of the strangest structures ever flown, a sunshield the size of a tennis court. It is built from 5 separate layers of a polymer called kapton, each one coated in aluminum, each thinner than a human hair. The layers are not pressed tight together. They are held slightly apart, so heat can radiate sideways and escape into the gaps between them. The effect is staggering. On the sun-facing side, the shield bakes at around 85 degrees Celsius. On the far side, where the mirror lives, the temperature plunges to roughly 235 degrees below zero. 5 tissue-thin sheets drop the temperature by more than 300 degrees. It is the most powerful sunblock ever engineered. But there was a catch, and anyone who has ever wrestled with a folded map could have guessed it. 5 gossamer membranes, each the size of a tennis court, had to be folded down to fit inside the rocket, then unfurled in space without tearing, snagging, or tangling. On the ground, that sunshield would become the single greatest source of heartbreak in the entire program. For a project this ambitious, the hardest enemy was not physics, it was time and money and patience. When NASA first dreamed up the telescope in the 1990s, the plan was to launch it around 2007 for roughly $1 billion. That estimate was a fantasy. Building something no one has ever built means discovering the problems as you go. The mirror technology had to be invented. The sunshield had to be invented. The folding mechanisms, the cryogenic instruments, the testing rigs, much of it simply did not exist yet. Year after year, the launch date slipped. The cost climbed past $3 billion, then 5, then 8. And in 2011, the United States Congress nearly killed the entire project. A House committee voted to cancel it outright, calling it a budget black hole. 3 decades of work, thousands of careers, the chance to see the first galaxies. All of it came within a single vote of the scrapyard. What saved it was a brutal reckoning. NASA restructured the program, set a hard cost cap near $10 billion, and Congress relented. The telescope survived. But surviving the politicians was one thing. Surviving the testing was about to be an entirely different ordeal. Before anything goes to space, it gets tortured on the ground. Engineers shake it, freeze it, blast it with sound, and bake it in vacuum chambers. Because it is far better to find a flaw in a lab than a million miles away. Webb's testing turned up flaws that stopped hearts. During one vibration test in 2016, technicians heard a rattle. When they inspected the hardware, they found loose fasteners, screws and washers that had shaken free from the structure during the shaking. Dozens of them. Each one had to be hunted down and accounted for, the cause understood, before anyone could breathe again. Then there was the sunshield. During a test deployment, the delicate membranes tore, small rips, but on a shield 5 layers deep and thinner than paper, a small rip is a catastrophe. More delays. More millions. The full observatory had to spend 100 days inside a giant cryogenic chamber, chilled to operating temperature, to prove the optics would hold their shape in the cold. Every test that passed was a relief. Every test that failed cost another year. By the time the engineers finally signed off, Webb had been built, taken apart, repaired, and rebuilt more times than anyone wanted to count. At last, the machine was declared ready to fly. There is a strange grief in finishing something like this. For 3 decades, Webb had been a thing you could walk up to, touch through gloves, adjust, repair. Now that was ending. The folded telescope was sealed into a shipping container kept scrupulously clean and stable, loaded onto a ship, and sent on a 16-day voyage. It sailed down the coast, through the Panama Canal, and across to a launch site on the northeastern shoulder of South America, Europe's spaceport in French Guiana, chosen because its position near the equator gives rockets an extra push from the spin of the planet. Their teams fueled it and folded it one final time into the nose of an Ariane 5 rocket. And then the engineers did the hardest thing of all. They stepped back. Some of them had spent their entire careers on this single machine. They had started as young scientists and were now nearing retirement. After this, no human being would ever touch it again. Whatever they had gotten right and whatever they had gotten wrong was now locked in. All that was left was to light the rocket and find out. On Christmas morning, the countdown finally began. It is the morning of December 25, 2021. In the jungle of French Guiana, the Ariane 5 rocket stands fueled and ready, the most precious payload in the history of space science folded inside its nose. The countdown reaches 0. The engines ignite, and the rocket climbs off the pad on a pillar of fire rolling out over the Atlantic. For the people who built Webb, the next 27 minutes are unbearable. They have handed 3 decades of their lives to a controlled explosion. But the rocket performs flawlessly. Stage separation, fairing jettison. And then, the part that mattered most, the rocket placed Webb on a path so precise, so close to perfect, that the telescope barely had to spend any of its own fuel correcting its course. That accuracy was a gift. The propellant Webb saved that morning effectively doubled its expected lifetime from around 10 years to potentially 20 or more. In control rooms across 2 continents, engineers wept and embraced. After 30 years, the machine was finally in space, sailing outward, away from the planet. But the celebration could not last, because the single most dangerous part of the entire mission had not even started yet. With the rocket gone, Webb was on its own. Ahead lay a month-long journey to its parking spot a million miles out, and during that journey it had to unpack itself in the dark. This was the sequence everyone had feared, the 344 single-point failures, firing one after another, with no one able to help. It began with the Sunshield. Over several days, booms extended, and the 5 paper-thin layers were slowly pulled out and tensioned, one at a time. Engineers later admitted this was the part that frightened them most. A single snag, a single tear, and the mission was effectively over. Each layer held. Then came the mirror. The 2 folded side wings had to swing out and lock into place, turning 18 separate segments into one continuous surface. The motors turned. The latches engaged. Mission Control confirmed each step with held breath and shaking hands. Day after day, a million miles away, in the cold and the dark, the machine unfolded itself exactly as it had been designed to. After roughly 2 weeks of major deployments, and a few more weeks of fine adjustments, the final latch closed. 344 chances to fail. 344 flawless firsts. The impossible telescope had become whole. Unfolding was only half the battle. Now Webb had to reach its home and come into focus. Its destination is a point in space called L2, a gravitational sweet spot a million miles beyond the Earth, on the side facing away from the Sun. There, the telescope can keep its sunshield aimed at the Sun and the Earth at once, sitting in permanent shade, drifting in a slow loop. As it coasted outward, it cooled and cooled until the mirror settled near 40 degrees above absolute zero, colder than almost anything in the natural universe. Then came the most patient task of all. Each of the 18 mirror segments had its own tiny motors, able to nudge it in steps smaller than a millionth of a millimeter. Engineers commanded those motors to inch the segments into alignment, slowly stacking 18 separate reflections of a single distant star on top of one another. For weeks, that star appeared as 18 blurry dots scattered across the frame. Then, gradually, the dots converged, until they snapped into one blazing point of light. The mirror was working. The optics were flawless. And now the machine was finally ready to do the one thing it had been built across 30 long years to do. It was time to open its eyes. On July 11, 2022, the world finally saw what Webb could do. The first full-color image was released, a slice of the night sky called a deep field. Hold a grain of sand at arm's length up against the sky. The patch of darkness it covers, a piece so small it looks utterly empty, is what Webb stared at. And in that tiny, seemingly blank patch, the telescope found thousands of galaxies. Galaxies in every direction, in every color, scattered across the frame like glittering dust. Some of them appeared warped and stretched into glowing arcs, their light bent by the gravity of closer galaxies sitting in front of them. And some of that light was almost unimaginably old. It had left its source more than 13 billion years ago, when the universe was a small fraction of its current age, and had been crossing the expanding cosmos ever since, finally ending its journey on a sheet of gold, a million miles from home. For the first time, humanity was seeing the early universe in sharp, vivid detail. Everything. The folding, the gold, the sunshield, the 3 decades, the hundreds of perfect firsts, all of it existed to capture that single ancient grain of light. And that first image was only the beginning. In the time since, Webb has rewritten parts of the textbook. It has found galaxies older and brighter than our models said should exist so soon after the beginning, forcing astronomers to rethink how quickly the first structures came together. It has peered into the thick clouds of gas and dust where stars are born, places ordinary light cannot penetrate, and watched new solar systems take shape. And it has done something that once sounded like pure science fiction. When a distant planet passes in front of its star, Webb can catch the starlight filtering through that planet's atmosphere and read which gases are present from the exact colors that go missing. Carbon dioxide, water vapor, the chemical fingerprints of alien worlds measured from 1,000,000 miles away. This is how humanity will one day search a distant atmosphere for the signature of life itself. The machine that was almost too hard to build is now, quietly, every single day, answering questions we have been asking since we first looked up at the night sky and wondered. Step back and look at what it took. 3 decades from idea to first light. $10 billion. Tens of thousands of people across more than a dozen countries. A mirror folded like origami. A sunshield the size of a tennis court. 344 chances to fail and not one of them taken. All of it aimed at a single goal: to catch light so faint and so old that it carries the story of how the universe began. And here is the part that still stops you cold. No one will ever service this telescope. There is no repair mission, no astronaut with a wrench. Everything had to be right the first time, and it was. A machine built by human hands, sitting alone in the dark 1,000,000 miles away, is right now quietly reading light older than the Earth itself. It was, in the most literal sense, built from nothing. From an idea that nearly everyone agreed was impossible, made real by people stubborn enough to spend their lives proving them wrong. If stories of impossible things getting built are your kind of thing, subscribe. There are plenty more where this one came from.